see a question, a shape, an obsession. It becomes a blueprint. I imagine what's next. Then come the systems, the depths. The momentum unravels. But I didn't choose this path to serve the process. The process was meant to set me free. To be fearless. To strive. To redefine what's possible. Unleash engineering brilliance. Trace.Space.
Hi, Neel. I think we're live. Thanks everyone for joining today. You don't hear me? Do you hear me now? You're just online. Hello? Do you hear me now?
Can you hear me okay?
Yeah, very loud and clear.
I can't hear you.
Does people hear me? Do people hear me? All right. Do you hear me now, Neel? I hear you.
My settings look okay.
Do you hear me?
Can Amanda hear you?
I think everyone hears both of us that are here. Seems like some tech issues as usual. But we see people coming in, and while we are figuring it out, perhaps people can put in the chat, where are you joining in from? I'm calling in from a sunny day in New York City today, finally warm again, after what seemed to be like a never-ending winter. Yeah.
Yeah, now I think I hear you.
Do you hear me?
Yeah, I don't know what happened.
Awesome. Awesome. Well, thanks for joining, Neel.
Thanks for having me.
Good afternoon, good evening, good morning to everyone joining in.
Yes.
Today,
Last time.
we are scheduled for 60 minutes. We might go over. Everyone will get a recording after. And I'm joined by Neel, who's worked in automotive systems engineering adjacent disciplines for the better part of the last 15 years. I'll let him introduce himself, but briefly about myself for those who don't know me. I'm Janis. I'm one of the 3 co-founders at Trace.Space, and I have been in systems and requirements engineering for the last 10 years because I was the first European employee for a company called Jama Software that people that are here might know. And even back then, I felt very frustrated seeing how little innovation there was at the product and tooling and platform space for physical product manufacturing and engineering and design. And I've always wanted to build something better. And about 4 years ago, we built the first backend for Trace.Space, and then AI came out, and that was a completely logical decision for us to build with an AI deeply integrated into the architecture. And so the Trace.Space is the first and only agentic AI native requirement systems engineering platform today. And as part of building Trace.Space, we've seen the AI change, improve, get better, help us build Trace.Space, but also help our customers build the products they are building. And also it's starting to become much more useful for systems engineering lately. So that's why I'm excited to speak to Neel today. And Neel, just to get things going, so tell us about yourself and where you're coming from and how has your experience been so far. It's been almost 4 years with AI now, so it's quite unbelievable.
Yeah, well, thanks, Janis, for having me. You're right in saying that I've been adjacent to systems engineering for better part of 15 years. So I spent all my career so far in automotive, in various engineering roles. Started in vehicle testing, full vehicle testing, and worked in research, developing systems like brake-by-wire, steer-by-wire, and developing full simulators. So writing requirements, testing them, and delivering the whole system. So when it comes to actually doing the full end-to-end system model V, that was probably the best example where start from customer level requirements and then deliver the whole system end-to-end. But I have not just been in systems engineering, and I'm not career systems engineering person. I have also been part of vehicle integration, vehicle engineering, as well as vehicle programs, and seen systems engineering or requirements and DV delivery from full vehicle program point of view, while leading the full vehicle program, delivering the full vehicle program. And because of that, in the last few months, I was involved more in systems engineering, or I was sucked into it because at Lucid, we basically, one of the core delivery for me was product definition. After creating the product definition, when we know precisely what all features we want to build, we need people to decompose those and start writing requirements at lower level, as well as start creating the system. But Lucid being Lucid, we did not have enough people to start working on midsize while people were still busy on previous program. Hence, I started getting involved more into it to try and deliver that and implementing AI-related systems to speed up things. So that's at high level something that probably is both relevant to this discussion.
Awesome. And you know, we've been around both a traditional legacy OEM, and then you joined a new software-defined electric vehicle manufacturer, and you've probably seen a lot of transition, a lot of change over the last 15 years in building complex products. And I'm curious, we speak to a lot of companies in this space that seem to struggle with this transition. There's just so much change. The pace seems to be increasing so much with the electrification, autonomy, AI, and systems engineering seems like to be seen as a bottleneck more and more. And I'm curious to hear your thoughts on where is this all heading, and do you see it as a bottleneck, or is this something that you see differently?
You're right in saying that it's been tough for a lot of people and both sides, because traditional system V model, as we know, focus more on waterfall, based on the system where you can predict what's going to be the life cycle. And it's not true for software development, as well as especially when it comes to AI created systems. I don't really see that it's the bottleneck. In fact, whether people name it or not, people do systems engineering to deliver complex system, period. It is impossible to have complex systems as we have today and not really do systems engineering. It's the way I like to explain to a lot of people internally, as well as if you talk of requirements, that's like tiny contracts between people, between teams, or between even customers. So vendors and suppliers and customers. It's effectively saying what you are aiming to deliver. And that's very important because you don't want to over-engineer. That's one of the things that people misunderstand outside of engineering, because everything has a cost. And if you think even from the simplest definition of quality, a quality product is the one that meets the requirement. It's as simple as that. So if you do more than what is requirements, it has to be at no additional cost. Otherwise, you are changing your requirements. So important to know what you are trying to deliver. And I learned that hardware years back when I was working on collaboration program with one of the tier 1 suppliers called Bosch. Some people might have heard of it. In that program, there were some targets that we were not very clear about because it was a research project. We wanted to be open-minded. And one of the partner told me that, but then how would you know that you reached? And that stuck with me. It's very, very true. You may want to keep an open mind. You may want to add new things at the end, but knowing at high level what you are planning to deliver is important, and then break it down. That's what systems engineering is. So you may hear Jensen Huang and a lot of other people talking about systems thinking. They may not name systems engineering, but systems thinking is effectively what you are applying in systems engineering. And that's nothing but thinking of the whole system and all the implications on each other. You're not thinking of each domain in silo. And if you think what NVIDIA is doing right now, it's exactly that. They call it, what do they call it? Extreme co-design. And extreme co-design is nothing but systems engineering. They are going after each and every aspect of what their ecosystem is and trying to optimize them for higher speed, better output, whatever. So, and they are doing it very correctly, going from 95% output to 96% output is incredibly hard. But if you can leverage that somewhere else in the whole chain, gain 5%, 10% much easily, that's the clever thing to do. And that's how they are delivering not marginal improvements like 25% or something. They are actually delivering 10 times, 50 times improvement every product launch. So I think systems engineering, sorry, it was a long-winded answer, but systems engineering is something that everyone's doing. It has been difficult to actually have the transition. And like we can talk about that more, but it is certainly not a bottleneck I see.
Talking about bottlenecks, how has your view on AI changed in the past 3 years? Specifically, because we seem to have a breakthrough every few months. into some new discipline, new way of doing things, software engineering agents. But at the same time, building physical, complex, safety critical products, you need extreme precision. And is AI ready for hardware, physical product engineering, systems engineering? And what have you seen? Has that made engineering teams more effective or just more optimistic in your experience?
So the extremely short answer is no. AI is not ready, but it's not just AI. It is more about deployment of AI and understanding the strengths and weaknesses of AI. There are many, many things that we collectively have to develop. So far, the AI that we know is probabilistic. We know that it tries to predict the next token, and that is excellent when you want to create requirements, author requirements, and that I see as an excellent strength. Even as a domain expert, you may want to start with that, and that gives you a draft that speeds up your authoring process. But there is also an element of everyone waking up to what AI can enable and where you need human intervention, human in the loop. And to give you some clarity, there is a big probabilistic aspect to it. And that is not purely on predicting the next token, but also during the VNV, when you try to do verification, the AI systems don't just rely on pass or fail, the traditional pass or fail that we are used to with traditional system V. It actually talks about what's the probability of this being correct with certain confidence. And if you think of that, that's how real world works. That's how we operate as well. So when, to give you an example, when we have advanced emergency braking in cars, that system effectively scans the road ahead and decides when to apply emergency brakes. And that depends on the confidence it has based on what it sees or perceives in front of the car or in either direction. But to clarify why it's probabilistic, it also depends on how the system is tuned by each OEM. It all depends on the approach that any company wants to take. You can choose to brake early when there is low confidence, but that means that you may have phantom braking. You may have braking when there is no obstacle or there is no risk of collision. And you may choose to do it when you have a lot more confidence, but at that time you will have less time to actually brake and react to things. So probabilistic pass fail is a big factor. It's something that a lot of people have not yet fully created structures around, and certainly not regulations. Regulations are lacking behind. So there are parts to AI that makes it not ready for physical world, and that's where the next challenge is. There is a lot of work that needs to happen, and that is not to say that it's not beneficial. It certainly is beneficial. I'm a big proponent of using it, and if you don't accept it, others will, and you will find yourself lagging behind in a few years' time.
Where did it bring the most value in your experience, your teams, yourself?
So the reason I insisted on AI is there is a distinct problem for a lot of companies who are trying to create something more innovative. In traditional OEMs, in traditional companies, you have requirements repository. Requirements are written over last 30, 40, 50, 60 years. And every new program, you have a big repository that a subject matter expert starts with. And they tick apply, not apply based on the content of the program. And only when you have completely brand new system within, let's say, a car, a new requirement is written. So the new requirement authoring is a relatively small part of the whole exercise. With new companies and companies which are trying to be very innovative, new requirements are a big chunk, and writing requirements is not very quick. So authoring requirements when you have less time, or even when you are an expert, or when you are doing something truly innovative and cross-domain, where the company does not have the skill set, at that time, using AI or LLMs to actually author requirements is speeding up process quite a lot. It gives you remarkable draft of things that you may not have considered. At least that's what I've found in my personal experience. And then, of course, you are the final gate. Human has to audit and accept that whether this is applicable or not. And that part, I think, is number one. Number two is traceability. A lot of time, the biggest problem with complexity in products like modern cars or rockets and stuff like that is that thinking about all the different aspects, if you make a change, what are the different systems that are affected by that? And that part is only fixed by traceability. If you have a system that basically traces all the links upstream, downstream, and triggers, if you try to change, instead of relying on your tacit knowledge as an expert that, oh, based on my 30 years of experience, this is what it means, which is what has been happening so far. If a system could flag that, okay, if you're trying to make this change, these are all these systems that are affected, and this change may not work because you have this or this constraint. That part is very, very important. That will speed up development quite a lot in the early part, but also it will prevent late changes and issues that people find late in final stages. So I think those two are currently prevalent, and then going forward, you will have more and more requirements added by actual live systems. So think of autonomous cars where it's driving around the world, constantly taking in the data, and then if it comes across a new edge case or use case, it adds to the stack of requirements. Similarly, for robots now currently going on in the factory shop floors, it's trying to constantly monitor that what's going on and then improvise to improve its operations. And that part effectively means that it is adding new requirements. So going forward, there will be big chunk of requirements coming from real world rather than being written by people.
That's actually a great segue into something that I wanted to ask you about. Is we can say that Lucid is a software-defined vehicle company, right? And we've seen that all these companies are hiring a lot of software engineers that traditionally don't have systems or hardware engineering backgrounds. How do you deal with this? Like, how do you actually handle the amount of change software, the amount of data coming in, and people that define the behavior of a safety critical product without knowing about systems engineering and formally learning about it? And where do you think we are heading with that? Because it seems like every product in the world is becoming software defined. Yeah, what are your thoughts on that overall trend?
So I think Lucid, despite of being more software forward company, it does follow systems engineering very well. And certainly there are people who come from pure software background, and they do sometimes struggle to comprehend the system view and need for that. But at the same time, it is not something optional, because as you said, the safety critical system means that you have to demonstrate that this system is going to be safe, and there are standards for that. So ISO 26262, you may have heard of functional safety. That's a very widely used standard. It's not a regulation, but it's a standard that is almost a regulation that everyone's expecting. So if there was a court case, they would expect you to have done that study. So to understand how that works, I personally think that it's a new, like traditional system V model has died a few years back. So the new one is more like a bloated triangle upside down. And you have iterative loops within each level. You have more of a hybrid where your system requirements are, or customer requirements are broken down into system and then component requirements, and you have iterative loops in those each segment, as well as when you go on V&V side, you have iterations there as well. But that does not mean that you go back and change the customer level requirements, because figuring out the architecture and then putting the orders through takes a while. So imagine you are coming up with a new car. You have to decide what segment or what size of a car that you are going to come up with. That's your choice as you set off defining the platform. That's when you can place order for certain things which are traditionally by very high lead time. I've seen lead times in hardware as long as 18 months. So, and 52 weeks lead time is not uncommon. So when you place an order for something, that's how long it's going to take before it actually comes to your factory. And then you will build the car, and then after all the logistics and everything, customer will receive it. So there is some flexibility with software, but there is certainly limitations when it comes to physical world. Hence, physical AI is when I think the next frontier is, where people would try and understand how to put these two together. A lot of people are doing that in practice. I already see a lot of things that we can do from this new sort of what I like to call is Relo triangle or bloated triangle upside down model, where we have ability to incorporate the iterative nature of software development as well as the aspects that come with AI. So something that I talked about, the probabilistic nature of requirements, the probabilistic nature of pass and fail, as well as when the new requirements are constantly added. There is a live requirement stack that is constantly adding new requirements to the stack. You are validating and constantly deploying that, which is what a lot of the autonomous vehicle companies are doing. But it's something that does not work if you just take pure traditional system view, for sure.
Another big news came out this week is that Apple changed their or announced the new CEO, a very formidable hardware guy, and sort of there's this insane AI hype going on for a while now. It seems that it's not going to be dying down anytime soon. Apple is not in on AI. At the same time, of course, their hardware software integration is amazing, and also most of their products are software defined. So I'm curious, what's your take on this nomination, and what does it actually mean for all of us in terms of where they see things are going in terms of AI, software, and physical AI?
Yeah, very good point. You are absolutely right that people normally perceive Apple as lagging behind when it comes to AI. But AI, so far, what people know is just LLMs, and LLMs is one aspect of it. What we would see in coming years is more applied in physical world. If you go by what NVIDIA announced, Jensen Huang announced in GTC this year, it was filled with robots. It was, and his explanation was that the next big challenge is physical AI. So, how I read and how I've also talked to a couple of friends who have been at Apple for some time, it is to bring. It's basically two aspects: bring the hardware innovation back, being the leader in coming up with new hardware, and the new sort of winning in AI would be in physical aspect. So if you think the new CEO has been the person behind all the new chips, the M1, 2, 3 that we know, I think it's up to 5 now. I think. So he's behind that. He's been behind almost all the hardware, as I read. I might be wrong, that Apple has shipped in the last 20 years. He's got his fingerprints on everything. So if you wanted to now start using inference on edge, Apple probably is the best suited. It has, like, I read somewhere that it has 2.5 billion devices. Now, you can basically have very different strategies. You can, we heard that when LLMs first became a thing, that models will keep getting more and more efficient, smaller and smaller, and then there will be time when you will be running them on your devices. A glimpse of that you already see. The new AirPods Pro 3 does live translation. So you can actually converse with someone who does not speak your language in a different language and listen to that. It's almost like you are sitting in UN and you have your personal interpreter speaking translated communication in yours. And that's effectively inference happening on device. So going forward, there will be more and more of that. And effectively what they are doing is systems engineering to not sound like a broken record or cliche, but they are thinking that what are the different elements of this whole system or ecosystem, and trying to go after others, because LLMs, developing frontier models, is expensive, and they may have chosen to not spend billions on that. They are just waiting that this is our strength. We will wait until industry is mature, and then we will use the models. And it doesn't have to be just LLMs, by the way. World models are becoming more and more applied in industry. So they may actually win in AI in coming years.
Yeah, that's the robots are coming. I guess that's something that we should all think about. They will be everywhere, and inference on the device seem like the natural path. But back to systems engineering. I'm curious also, where do you think it goes next? Because you already mentioned that there's there's no traditional V model. And then at the same time, in the academia, in professional bodies for systems engineering, this is, it's not something that you can hear about. While at the same time, you do hear that the traditional V model is dead in these modern, fast-moving hardware scale-ups. So how do we bridge that gap, and when is it going to happen, or what needs to happen for that to happen?
Question, and I think it's already happening. Some people are doing it consciously, some people are not doing it consciously, but they will realize that they will be dragged into it. So I'm firm believer that systems engineering has to happen when you want to deliver complex systems, and there is no going around it. Anyone who thinks that, I don't want to break the internet, but I find Elon Musk being very intelligent in many aspects, but sometimes when he says that all requirements are dumb, I cannot agree with that, because yes, you questioning requirements, absolutely. If you have requirement repository from 40 years back and whether they are applicable or not, absolutely, yes, do that. But if you don't have requirements, you cannot actually have those contracts between the teams that this is what we are going to deliver, as well as when you Tesla traditionally very famously owns big stack. They are vertically integrated and they own big part of the whole supply chain. But when it comes to you working with suppliers and vendors, you do need to share requirements. You have to specify that this is what we are ordering you to deliver. So not having requirements or saying that all requirements are done is also not very intelligent. But people, to going back to your question, people are developing that. And the way I see it is there are probably 3 levels of how industries using AI and systems engineering. The current way that I see most people using it is using LLMs like Copilot or ChatGPT to correct your requirement draft, get a requirement draft. That's the level where I think almost everyone is. Some people who are a bit advanced, they are in level 2, where they have more structure around the way they do systems engineering and requirements and test, where they have traceability, they have context of what is the question. So depending on what system of the whole car, let's say, you are focusing on, your requirement would have different content. So let's say a pass-fail test for brake system would be very different versus a pass-fail test for infotainment screen. So the context, and that's something that we worked heavily at Lucid as well, where to try and figure out what is your context when you request something from LLM, let's say draft requirements for Apple CarPlay. Knowing your platform, your architecture is very profound. That dictates what would come as the lower level decomposed requirements. And that's, I think, is where some of the leading teams are. And when it comes to more and more in the next immediate future, I would see more and more teams using that, having more structure around the providing the context to LLMs, that this is what my current assumptions are, my current architecture is. Now, what are the possible requirements? And the level 3 I think, would be where we will have systems which are largely written by AI. And that may make a lot of people uncomfortable, and it probably justifiably is. So in some part, it's already happening. You know that all these AV companies are constantly taking in information based on the perception they have and constantly adding to their stack. Now, if you keep doing that for more and more systems, and AI is contributing to requirements, you end up with a system which is similar to LLMs, where they are not really something that you can look into. So far, we have designed systems. I have designed systems personally where we write down the whole architecture in MATLAB Simulink sort of environment, and then write down each and every input and output. When you have big neural networks, you can't really see into it. And those are dark systems or black boxes in some sense. And at that time, the strength would be people who know what are the things that AI does well and what are the things AI struggles with. So auditing the requirements and figuring out how do we sign off a system would be the strength. So systems engineers in future, I don't think would write requirements. They would actually audit requirements, and they would know how to sign off a system. And something I read, there was a paper that came out recently where they talked about something that really resonated with me: provable probabilistic safety. And what they were saying is that going forward, when you are talking about real world, and scenarios are not enumerable, you have plethora of scenarios. How do you actually sign off? You cannot test all those millions of scenarios. How do you actually sign off a system and say that, yes, this is safe? And they're saying that there is a way to do that where you take that from the statistical probabilistic approach point of view and demonstrate physically the chosen examples or use cases that demonstrates that this is the big chunk of the scenarios, which now gives you the confidence that this is how it is, the system is safe and it will work safely in biggest chunk. And then I think the paper goes into detail to explain for the remaining part, which hasn't been shown completely, which is the low probability edge cases. It also goes into explaining how you can tackle that to reduce the likelihood of failures even in those cases. So signing off a system, whether it's cars or robots on factory floor, saying that these are actually safe, that's going to be the sort of task of systems engineers in the future. And some like regulations will have to follow. Some of that is already happening. You see, there is a new sort of regulation where I think it's PS 8800, where it talks about how you have to demonstrate that your input data in the system is taking care of all the use cases that you are trying to address. If your data does not have that, you cannot say that this covers that use case. So there will be, this job will shift, as a lot of people are talking about, that your job will move from writing requirements to now making sure that you are signing off them correctly, you are auditing them, as well as making sure that data input is also signed off, because what data you feed, the quality of that, the legitimacy of that data is also just as important.
Yeah.
Sorry, long-winded answer.
Yeah. You answered several of my follow-ups in one, but it seems like there is a lot more testing happening already, just to prove that you are safe to release the system that you are building. But at the same time, you mentioned that it's not possible to test all of those scenarios because there's just too many. So you have to test the ones that are the more likely to fail, and you do that by statistical models to figure out which ones to test for. I'm curious, is the engineering tooling keeping up with that? And I mean, we have the traditional vendors, the salts, the PTCs of the world, and they built some stuff, they bought some stuff, they've integrated some stuff, but to me, it seems like things are moving faster than ever. And how do teams even keep up, also from the tooling perspective? Where do they keep the data for that?
It's a real challenge. It's not a joke. It is a big pain point in every company. I know I've worked with a lot of companies within automotive, outside as well, recently with NVIDIA as well. And NVIDIA, by the way, also follows Model V for where it applies the safety critical systems. But it's not, the tooling has not kept up. And as you said, that yes, the rate of change is so fast. Tooling as well as regulations have not kept up. And I think the traditional tool makers are also probably waiting on guidelines and regulations and standards to create their systems such that they will follow those. But because the regulations and standards are not actually coming as fast as industry is moving, it's lagging behind severely. And that's why I think the platform that you have helps in some way. And I think if you wanted to go to level 2, as I was discussing, that's possible today. You have all the traceability, agentic intervention to basically check your requirements before you say that this is the requirement. And going forward, we would need more and more that caters to level 3, where systems engineer becomes auditor rather than someone who writes a requirement. Because systems engineers are generally subject matter experts on any given domain. Their time should not be wasted on keeping up requirements when they are constantly changing.
Right. Actually, on the topic of tooling and AI, what are your thoughts and what have you seen on enterprises building their own tools with AI? Well, seemingly, and anyone now can slop or prompt an internal tool with the modern LLM solutions. I'm curious just to hear, has that worked for you? Have you seen it work? Where do you think this is heading? And also, another trend that I see is there are more companies that do LLM-based simulations, like PhysicsX, for example, where you have an AI-based simulation engine which just cuts down the time that you can analyze different kinds of parameters. And then that means that some of the engineers are very advanced prompt engineers because they can both improve their own internal tooling but also test different parameters and model and simulate them right away. And so sort of, do you believe in that kind of engineering future?
I think you have two questions there, and I'll try and answer them. The first one being that what's happening, and I think it's honestly chaos, because everyone feels the presence of AI and LLMs, and everyone's trying to utilize that. Everyone's trying to speed up, and they, as you know, that just general expectation of speed is very high in all the industries. So finish your work and then do that for everything that's changing is quite a lot of demand. So everyone's trying to do that, but I have not seen any company having a very cohesive process and tool set to support that for the whole organization. And that's where I see that individuals or small teams within the companies try and do something of their own, use either sort of unqualified tools for themselves, or create something which is not really context based. So something that we discussed a few minutes back, where if you are trying to use AI for things like writing requirements, V&V, being thorough, being deterministic, or being precise that yes, this is actually the answer is important. And everyone knows that. But when you don't fully understand the strengths and weaknesses of LLMs and do that in silo, the output a lot of time is not context based. And if you don't pay attention, it can be recipe for disaster. And a lot of time it is impossible for the gatekeeper like chief engineer or someone of that capacity to go through all the requirements. It's like hundreds of thousands of requirements for one car platform. It's impossible for someone to actually, or a team of chief engineers to actually go through them and audit all of them. So I actually, if I was to advise any exec team, which I have done at Lucid as well, I would really, really urge everyone to start using it. Think of it in a more structured manner. Provide process and tools to the team so that they can actually use something that is thought through, and there is some guidance that these are the strengths and limitations. And finally, it is the person who's writing the requirement who's liable, who's responsible, not the tools. So I don't know if I've answered your question. I think what I was trying to highlight is that people are using it because there is energy and people see the value, but it's chaos.
Well, that's a fun time overall. That I agree, quite intense. Is there anything that I haven't asked today that you want to share or want to open up as a topic today?
I think we've covered everything, things that we normally struggle with. Something that I have seen people who are like, when you have two worlds collide, physical world and software world, where people come from either a very pure software background or very pure hardware background. The biggest challenge I see is in approach to systems engineering. A lot of people struggle to comprehend the life cycle. So to simplify for all the audience here is, when you have a car platform, when you are coming up with new architecture or platform, usually that lasts for 7-10 years, and development also takes years. I talked about the lead time. So when you agree on an architecture and place and order, sometimes the lead times are as long as 18 months. And 52 weeks lead time is not uncommon. So in the same context, when you want to put software where the development is iterative, people also, because thought leaders like Andre Karpathy have said that software 2.0 and now 3.0 basically killed software 1.0 as well as the requirements as it was. And system model V, it sort of confuses people to misunderstand that it is iterative throughout. What it's not is that you don't basically go like if you start from top level, these are my customer level requirements. You break it down. Now we are doing the component level requirements. If you find something that is challenging, let's say the customer level requirement is that we want a car that does 0 to 60 in 3 seconds. Now, based on something that you are doing at level 4, you find that, oh, actually, that's difficult to achieve. It does not mean that you go back and say that now we are changing that 3-second requirement to 5 seconds. It means that you are doing iterative development at each level. You're not going and changing requirements up top, because ultimately that was your mission. You started with a customer requirement. That is what you set out to deliver. If for some reason you cannot deliver, you cross-functionally agree that we are going to deviate from this requirement. But it does not mean that you are constantly updating them. So a lot of people struggle to comprehend that there are requirements which are permanent that you are trying to deliver, and then there are new requirements being added based on these AI systems that we discussed about. So, but those systems don't mean that you are changing the architecture, because you can't. Even the fastest companies like Tesla, for example, I read about the news a couple of days back that they are now offering people to upgrade their hardware from HW3 to HW4 or something like that, which will allow them to basically have the latest full self-driving, which means that those cars were fitted with something that was capable of doing up to a certain limit. And when you try to go beyond that, it's not like software where you can OTA the update. So there is always going to be two aspects to that. One that is live new requirements coming in, and one that was pre-written when you started. And another good example I think of it is, there's a very classic test in automotive called Moose test. In vehicle dynamics, there is a test which effectively tests the stability of a car. And the actual legal test might not be called Moose test. It might be called sign test or something like that, where you're supposed to demonstrate that a passenger car does double lane change at least 45 miles an hour. And then it's deemed safe, that it's not going to roll over or something like that. And Moose test, if you know the moose, they can be 1,000 kilograms. So if you think you are on a Scandinavian highway, frosty day, it's not very bright. Do you expect Model 3, if someone is driving, to actually encounter that, take that into account, avoid the moose, and send that information back to mothership saying that now let's add that as the new requirement? Unlikely, right? So, and let's say that Model 3 crashes into the moose. What's the likelihood of that Model 3 coming out okay? All the compute and sensor stack on the car is okay, and it now sends that information back to the mothership saying that let's add this as the next requirement. Unlikely. So you have to write that as the requirement to start with in the program, and then you can keep adding new ones as you come across and deploy them. You see that it's validated and it's signed off and it's safe. So I think there is a lot of thinking that needs to happen, and it is going to be more and more cross-functional as I see it. And that's why I think I respect Jensen Huang's approach of extreme code design quite a lot, because ultimately, when you understand the whole ecosystem, that's when you can improve things very well. I think that was one of the things.
Yeah, amazing. But that made me think that actually then in case of Tesla, they also had to have a requirement that the hardware needs to be upgradable. Not only the software needs to be upgradable OTA. So both can evolve at the same time, which is something that we haven't really seen in the past.
So hardware needs to be upgradable is something that even we considered. It's not, I don't know how written requirement that was. It's always possible, but at a cost. And we decided at Lucid not to do it because the cost to customer and cost to company was too high. So it did not remain practical. But it's possible to always do that. You can always retrofit things. And I think their SpaceX is one of the good examples where it's reusable. So you are refitting it with certain hardware that's required for the next one, but you are reusing as much as you can. So it's possible, but at a cost.
Nice. Well, it's been very insightful. We are up on time. I wanted to thank you for joining me today, and thanks everyone who joined. It was a pleasure speaking with you, and I hope to do it again.
Yeah, thank you for having me. It's a very interesting subject, and certainly keep doing what you're doing, I would say.
Awesome.
Awesome. Thank you.
Thank you.